Physicists widely believe that the universe began with a colossal event known as the Big Bang, which occurred around 13.7 billion years ago. But one fundamental question remains. What triggered this explosion, and why did it happen? For decades, scientists have studied the history and structure of the cosmos, with the Big Bang theory serving as a dominant explanation for nearly everything we've observed. Thousands of researchers and countless studies have supported this theory, pointing to a universe that has been expanding ever since that initial moment. According to the theory, a mysterious force known as dark energy, even more abundant than the energy within galaxies, is responsible for driving the continued expansion of the universe. However, modern science has evolved dramatically. With every new technological breakthrough, fresh perspectives and alternative theories emerge. History has shown us that many ideas once considered absolute truths can eventually be overturned. Recently, renowned scientist Mishoku has questioned the validity of the Big Bang, suggesting it may have been officially debunked. Why? Because the James Webb Space Telescope, JWST, has detected over 750 newly identified galaxies, and they look nothing like what our current models predicted. This discovery is opening up a new chapter in our understanding of the universe. Join us as we explore how the James Webb Telescope is transforming what we thought we knew about the cosmos. If you're passionate about space, science, and groundbreaking discoveries, make sure to subscribe to our channel, like this video, and turn on notifications to stay updated. Share this with others who love the mysteries of the universe. The images captured by JWST are breathtaking. In just a single frame, hundreds of galaxies are visible, each one an awe-inspiring testament to the scale and beauty of the cosmos. While these visuals captivate the general public, they've left scientists baffled and even alarmed. Why? Because the galaxies revealed don't align with what cosmologists expected based on the Big Bang model. Not only are these galaxies more numerous, but they're also smaller, smoother, and far older than predicted. One research article even uses the word panic in its title, reflecting the shock these findings have caused in the scientific community. For decades, the Big Bang has stood as a foundational theory for explaining how our universe began. But the latest data from JWST challenges this long-held belief. The galaxies captured appear too small, too smooth, and too ancient to fit within the standard Big Bang timeline. They are also 2 to 3 times smaller than similar galaxies previously imaged by the Hubble Space Telescope, an observation that contradicts expectations in an expanding universe. According to the Big Bang model, distant galaxies should appear larger as the universe stretches, yet JWST reveals the opposite. Even more puzzling is the unusual smoothness of these galaxies. Based on current theories, galaxies from the early universe should exhibit irregular, clumpy structures due to turbulent formation processes. However, the galaxies in new images look unexpectedly well-formed and smooth, lacking the complexity we'd expect at that stage of cosmic evolution. In short, these revelations are causing scientists to reconsider the timeline and mechanics of galaxy formation, and even the fundamental story of how the universe began. As we uncover more about these mysterious galaxies, the very foundations of modern cosmology may be rewritten. According to current scientific theory, at the very beginning of the universe, all matter, energy, and the fundamental building blocks of the cosmos were compressed into an unimaginably dense and compact point known as a singularity. At this singular point, density reached infinite levels, where matter and energy were squeezed into an almost zero-volume space. This concept arises from our current understanding of physics, particularly Albert Einstein's theory of general relativity. Within the singularity, everything that would eventually form a universe existed in an extremely concentrated form. The sheer amount of mass and energy present meant the temperature was beyond anything we can observe or recreate today. This searing heat and intense pressure stored the energy that would later explode outward, seeding the birth of our universe. This event, known as the Big Bang, marked the origin of everything. From that singularity, the universe began a process of rapid expansion and inflation about 13.7 billion years ago. In mere fractions of a second, space itself stretched exponentially faster than the speed of light, a phenomenon known as cosmic inflation. During this phase, space expanded so rapidly that it smoothed out irregularities, spread matter more uniformly, and laid the groundwork for the large-scale structure of the universe. This process ultimately led to the formation of galaxies, stars, and other cosmic structures. As time passed, the pace of this expansion slowed but continued steadily, a phenomenon we now refer to as cosmic expansion. We know the universe is still expanding because of a phenomenon called redshift. As galaxies move farther away, the light they emit stretches to longer, redder wavelengths, providing direct observational evidence of this ongoing expansion. In the early moments after Big Bang, all matter was packed into an impossibly small volume. Under such extreme conditions, matter couldn't exist as we know it today. But as the universe expanded and cooled, fundamental particles like protons, neutrons, and electrons began to form and interact with surrounding energy. These early interactions led to nucleosynthesis, the process that created the first elements in the universe. For a long time, astronomers believed early galaxies would appear chaotic due to frequent collisions and mergers. However, the James Webb Space Telescope, JWST, has surprised scientists by capturing images of highly organized spiral galaxies in the early universe, structures that look strikingly similar to modern galaxies. This contradicts a long-held assumption that galaxies grew larger primarily through repeated mergers. If these newly observed galaxies haven't undergone many collisions, it suggests they may not have started as small as once believed. This discovery also challenges the optical illusion expected in an expanding universe, where distant objects should appear smaller. Yet, JWST's observations don't align with that prediction either. Additionally, the age and number of galaxies revealed by JWST cast further doubt on the standard Big Bang model. Using its advanced infrared imaging, the telescope allows scientists to study the colors of distant galaxies, helping estimate their ages. Many of these galaxies appear much older than the Big Bang model would predict for their distance, prompting astronomers to question whether our current cosmological model needs revising. If you found this video interesting, make sure to hit the like button, share it with others, and subscribe to the channel so you never miss an update on the unfolding story of our universe. Don't miss our next update as we dive deeper into groundbreaking discoveries made by the James Webb Space Telescope, JWST. Discoveries that could fundamentally reshape our understanding of how the universe began. As astronomers continue to sift through JWST's vast datasets, new theoretical models are emerging, some with the potential to challenge or even replace the long-standing Big Bang theory. A growing number of scientists are exploring alternatives, such as a steady-state or cyclic universe models, where the cosmos undergoes endless phases of expansion and contraction. Others are delving into bold ideas involving quantum gravity or multidimensional frameworks, suggesting that the universe's origin may be far more complex than a single explosive event. What's becoming increasingly clear is that we're standing at the dawn of a new era in cosmology. JWST's discoveries aren't just challenging old paradigms. They're opening doors to innovation across physics, astronomy, and even philosophy. Once purely metaphysical questions, like whether the universe had a beginning or if it will ever end, are now the subjects of empirical science. This scientific shift is a reminder of what makes science so powerful. It evolves. The truths we hold today may be revised or even overturned tomorrow. As long as we continue asking questions, exploring the unknown, and staying open to new evidence, we remain faithful to the core spirit of discovery. By peering deep into space, we're essentially looking back in time. The light captured from distant galaxies has traveled billions of years to reach us, offering rare glimpses into the early universe. However, what we're now seeing doesn't always align with what the Big Bang model predicted. This mismatch is pushing scientists to rethink established ideas about the universe's structure and timeline. Some researchers argue that the new findings don't necessarily disprove the Big Bang, but suggest our understanding of galaxy formation is incomplete. Perhaps early galaxies formed much faster or under very different conditions than previously assumed. Others believe we may be witnessing the influence of unknown forces or particles not yet included in our current models. Even the concept of cosmic inflation, introduced to address early inconsistencies in the Big Bang theory, is being called into question. The unexpected structure and timing of early galaxies may indicate that inflation occurred differently than theorized, or possibly didn't occur at all. This has reignited interest in previously fringe theories, such as the ekpyrotic model, which proposes that our universe began with a collision between higher-dimensional brains. Roger Penrose's conformal cyclic cosmology, which envisions an eternal cycle of cosmic death and rebirth. While these ideas remain controversial, JWST's data is bringing them back into serious scientific discussions. At the same time, advances in telescope technology, sensors, and data analysis, combined with AI and machine learning, are giving scientists unprecedented tools to analyze and interpret these cosmic revelations. These innovations are becoming essential in spotting patterns and anomalies that may hold the keys to new theories of the universe. One thing is certain: we're entering a transformative chapter in astrophysics. The discoveries emerging from JWST aren't just scientific, they're philosophical. They challenge our understanding of space, time, reality, and humanity's place in the cosmos. As we await further peer-reviewed findings and continued exploration, it's vital to remain both skeptical and open-minded. Science thrives in the tension between doubt and discovery. The universe is not obliged to fit our theories. Our theories must rise to meet the universe.